Now, starting off with the control and looping statement. These three will be the basics. So we'll start with if, then go to else and elif, and we'll also see how to make nested control statements. So these right here are the control statements. After doing this, we'll go here. So let's start with the if block. So how do you write the if block? With if block, we have the if keyword followed by condition. It must always be something Boolean. So Boolean means true or false. And if true, it must print I. So it prints you I. So this tab space, or like when you do it automatically, Jupyter Lab assigns you a tab space or this amount of space. So this is what separates this from something like this. So this print high is a part of the if block, while this print high is not part of the if block. So this means if block has ended and you don't have something like a closing braces or something like that. As long as the indentation is there, it's all part of this block. Print by, this is also part of this block. Now, this will be printed no matter what. But if this is false, it prints, let's put something here, it prints only this. Because if it's false, everything within this block won't be running and it will go to the next line of code outside the if block. So instead of true or false, you can return anything that gives you a Boolean value. Like 3 greater than 2, it's true, so you get whatever is printed here. If 3 is less than 2, it's false. You can even use equals operators. Or let's see, 3 not equal to 2. That's a true. So these are printed. Apart from that, we'll do these also, but let's go on to the else part. In the else part, if the if condition is true, if is false, it prints the else part. So give else and print Ohio, because this is true. If the if condition is true, else won't be part of it. And if this is false, it prints the else part. But without the else part, it doesn't print anything. It just skips the block. So it skips and goes to the else part. But if this is true, it goes right here. It goes outside. And note that there is also the tab space to define what is inside the else block. That's else statement. Elif is a combination of if and else. So we specify it between else and if. But the other thing to be noted is that you can have if condition alone, but you can't have the else block as it is. Just give you an error. After the if condition, only the else block can come. It can't come on its own. And also, it's similar to elif. Elif can't come after the else, but it can only come between these two. So let's give this and print elif. Condition here, because it's a combination of if and else, let's give 4 equals 4. It prints elif. Why? Because if this condition is false, it goes to elif. If elif is true, it prints elif. If you have multiple elifs, I equal to 5, print elif2. It prints you elif. Why not elif2? Because this loop runs until a true statement. So if all the if block and else block is false, at the end it will anyways run the else part. But since this is true, it just goes directly here. Print end. So after this statement is true, it directly jumps on to this part. So these won't be executed. But if this is false, you can see it goes to this one because it's true. That is also not true. It goes to else. So if all these are false, it goes to the else part. You can have multiple elifs here, but suppose if you put an if here, if statement, if 5 greater than 4, print L2. So here it prints L2. Let me just change this. So it prints elif2 also, and it prints L2. Why? Because this if condition is not the continuation of this block. When a new if condition comes, it's an entire new structure. It's entirely a new portion. So this is one part or a set of if, elif, and else, and this is another set of if, elif, and else. So that's how we deal with if, else, elif. For nested loops, if 4 equal to 4, we can have another if here. If 5 equal to 5, let's give 5 not equal to 5. Print 5. Else print out 5. And we could even have our elephant elif if you want. Even this if statement alone is sufficient. Like you could just run this here if you put something like hi. So what it does is if this statement is true, it goes into this and it starts with this. This 5 not equal to 5 is false. So this doesn't get printed. And it goes to the next line inside the if statement, which is this. And then this is just a print statement. So it prints it and moves out of the loop. Even if you put an else statement here, else print by, this else is part of this if. But if I put an else here, make sure the tab space is there. You should also have a tab space. Print. Hello? Did it show an arrow? Okay. Since this print statement is there, it breaks it from the if loop. So after if, else should come. That's why it showed an error. Let's just have the print statement here. So this is not true. This gets printed. So this is an if loop inside an if loop. And if this loop is false, it's going to ignore the whole thing right here because this is false. It jumps directly to the else part and it prints this. So that's how nested works. Coming on to in, not, in, and, nor, we have seen these two in our list tuple sets topics. And coming on to in, we have if one in, let's take a string here. If a in apple. So we know that this thing returns true. So print hi. Hi is printed because this is same as true because this statement returns true. So this loop starts running and so. Coming on to not in, A not in apple. But A, since A is there in the apple, this is false and this doesn't get printed. And if you want to have multiple if statements, if conditions, like I want 1 greater than 2, you put and here and give 3 greater than 4. Both are false, so nothing. But if I just flip this over, it's a print to nothing. Because for and to be possible, you need this and this to be true. So only if both the conditions are true will it print high. But if you take the case of or, if both the conditions are true, it will print you high. If either one of the conditions are true, then also it will print you high. But if both the conditions are false, it doesn't print you high. And what if I do a mix of it? You can even have another or you can have and. So how does it take into consideration if we have another or and here and I give 5 greater than 6? Let's see. This is true. And let's keep this as false. And this is false. Let's put this as true. And 5 greater than 6, we'll make this false. So it's false, true, false. But if I run it, I don't get an output. Why? But this is true, this is false, then it's an or. Why doesn't it work? Because you start from this side. So you take this condition, this as the first one, and you check these two. What does these two return? This returns false. And this gives you false. So false or false is false. So that's it. This gives you false. If I give or for less than 8, we start from this side. Does it give you anything? It gives you high. Why? Because this much gives you, this is true and this is false. True or false with an or gives you true. Take it with this. This is true and true gives you true. And this thing, true or true, this is not true. 1 is not greater than 2. So false or true gives you true. So it prints you high. So you take it from the right side to the left. So that's how and or works. Coming on to some of the basics we need to start with the for loops and the other looping statements. First one is we have pass. We'll do this pass in if statement. Starting off, if I give something like 4 greater than 5 and run it, I don't want to give anything here, like no print statements. It gives an error. So if you want to run the code like this without giving anything inside and you want to like put the code in later, just put pass. Without the pass, it will give you an error if you leave it empty. But if you specify something like print or some another command here, it won't give an error. But if you just want to place it as a placeholder or something like that, just put pass and you can run the state. So that's how you use pass in if statement. Coming to range, we have taken many examples of lists before. Let's take a list again, and I'm going to have to type till 7, 8, 9, and so on. But what if I want till 100? You might type it till 100. What if I want till 1,000, 10,000, 1 million? That would take a lot of time. So instead of typing it till there, we type range of start, stop, and step. So all of them need not be there. So each one has its own use. So if you type range, you can't type it right here. So you need the list function. And before taking the list function, let's make a mistake and learn from it. I took list is equal to 1, 2, 3. And now if I take list1 is equal to list function of a tuple 1, 2, 3, I get an error. Why? Because this was a function and I assigned the function to a list. So now this is no longer a function, but it has become a variable. So now it's impossible for us to get this list back. So in such cases, what you can do is you do del of list. And now if you run list1 is equal to list of 1, 2, 3. There you made your list back. So remember, if you make a silly mistake like that, just delete the list and the list function will come back. With that on the line, let's move on to the range. List1 is equal to 1, 2, 3. We're not doing that anymore. Just our list range of. If you give 10, let's see the output. It gives you from 0 up to 9. So whatever number is given here won't be included, and it will go start from 0 and go till this number minus 1. So 0 to 9 is its range. But if I want to have it between two numbers, if I give 20, you get it from this number also included here till this number minus 1. So it only goes till 19. So 10 to 19. In the same way, I can give 0, 20, which is just from 0 to 19. But the thing is, the length of this will be equal to this. And coming to step, which we have seen in slicing, if you give a step of 2, look at the output. It jumps 2 steps, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. And if I want it till 20, let's give 21 here, and I get till 20. So this can be used to print all the even digits till how much ever you want. So that is the use of step. Giving a step of 3 gives you the multiples of 3. You can even have it from 10. It starts from 10, increments 3 each time. So that's how you use range, and these are the 3 parameters. Break statement and continue statement, these we will use in our loop, but let me just define them for you. The break statement is used to completely jump out of a loop. So if you're in the loop, the loop is going to run multiple times, 2, 3, 4, 5, and so on. So if you're in the loop, it means it just gets out of the loop. It goes to the next line of code. But instead, continue on the other hand, let me just take a point. Continue on the other hand, if I type continue here, continue, before running the second one, if there's a continue here, it means it skips this loop, and from 1 it directly jumps to 3. We will see it in detail right now. So there we are at the for loop. Okay, so the for loop starts with the for keyword with for I, This can be anything, any word you like, which could be meaningful and understandable to you. For I in keyword with, let's use the range function for now. In range 10, remember there's a colon here, print I. So let's start with I. So it prints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it prints 10 times high. But if I want to print the value of I here, it starts from 0 and it goes till 9. So in the first loop, I gets the value of 0 and it goes into this for loop. And the only statement here is I print I. So it prints the value of I. Next, it goes to the next loop or the second loop. I gets the value of 1 and it prints 1. And it goes on till I gets the value of 9, which is the last value here. And it prints it and it exits from the loop. So if I print here high, so this is not part of the for loop because we have removed the space right here. And so after the loop is done, it goes on to the next statement. So that's how the for loop works. You can even do all the basics you have learned in here. If I give 10 to 20, it prints from 10 to 19, gives steps of 2, and whatever was given with stepping of 2, like 10 to 20, it prints all these numbers one by one in a specific loop. So that's how you use the for loop. And coming back to break and continue. If I give break, space, tab space, or if you would just use a small space, it still works, but readability and something like an organized way, we always use tab space. Break, it doesn't print anything. If I give print statement here also, print I, doesn't print anything. Because when it gets the value of 10 and it goes into the loop, it immediately goes out of the loop. It goes out of the loop. But if I give my break statement right here, it just prints 10 and goes out. Why? It prints this, but when it reaches next itself, it reaches the break statement and it just moves out. It goes out of the whole loop and goes to high. We can even have this thing locked behind an if loop. If I is equal to 14, then only break the loop. It goes to 14 because it first, when it gets the value of 14, it prints it first. Then it goes to the break statement. And since this value is true, it prints break. Other than that, what if I give it like this? It doesn't print 14 because before printing, it checks for the condition first and then it breaks from the loop. But if it is not equal to 14, it only prints high. Why? At the start itself, it gets the value of 10, but 10 is not equal to 14. So it just breaks from the loop. So that's the for loop with the break condition. But if I give here continue, what it does is, as long as this statement is true, it just continues. That means when you give continue, it doesn't execute whatever is given below it. So below it, if you even give print I, anything below it, it doesn't print it. It just printed this high for the 14th loop. Let's give a value which is not there. So as long as this continue statement is running, so when it reaches here, it just goes back here, like right back to the for loop and the next loop. So if I just give without the condition continue, or it doesn't print you anything below it, because when the loop starts, when the for loop starts, it just continues and goes back into the loop. So it goes back to the next cycle of the for loop. So we can also give conditions like if I is equal to 14, I is equal to 14, continue. So 10, 12, it doesn't, when it reaches 14, it just goes back to loop. So this is not executed and it goes to 16, 18. So in break, we have seen that when it reaches 12 and this condition is true, it just goes here. It goes to the next line of code. But in continue, it goes to the next iteration or the next loop. So that is break and continue. Nested for loops, let's learn it. I'll make it super simple. For I in range 3. So what do you think the range of 3 can give you? 3. So it gives you 0, 1, and 2. So we'll have another loop, j in range 3. Print I, comma, j, j. So what it did? 0, 0, 0, 1, 1, 1, 2, 2, 2. But here you have 0, 1, 2, 0, 1, 2, 0, 1, 2. Which means this loop starts running, I gets the value of 0. And it goes to this loop. And this loop keeps running again and again. And only after this loop gets over, it goes outside and comes back to this loop. So it gets 0, 1, 2, and this loop is over. So it breaks out of this loop. And since there is no code here, if I give a print statement here, you can see after this loop gets over, then it goes to the next line. And after this line gets over, the loop is, there's no more inside the loop with any indentation. It goes back to this. So now I gets the value 1, and this loop starts running with j as 0, 1, 2, and I gets 2, and it runs at 0, 1, 2. Let's complicate it a little bit, like for k in range 3. Print I, j, k. As you can see, first the topmost loop, then this one runs 3 times, and this is just 0, 1, 2. So it goes from here to here to here, and then it trends. So it's the same logic, but 3 times. So we can see this one, but just in one loop, this one gets the value of 0 for 1, 2, 3, 4, 5, 6, 7, 8, 9 times. But this gets the same value for 3 times, but this is only 1 time. So you might understand the logic that goes in here. You want an explanation in detail? If you didn't understand, for those who didn't get it much, let's take a for loop, and a for loop. I in range of 3. This is j, this is k. So in the first loop, in loop 1, I get the value of 0. And it goes to this loop. Let me write it down real quick. 3. it goes to j. So j can have 0, 1, 2. For the first loop of I, j will be running 3 times. And it goes from there to here. So for this 0 loop of j, this k gets 0, 1, 2. For this one, it gets 0, 1, 2. For this, it gets 0, 1, 2. So in the same way, when I is 1, this whole thing happens again. So like that, 0, 0, 0, 0, 0, 0, while these two are constant, this k is changing, and since this k is over, it jumps back to j, and it's still 0, but j becomes 1, and it runs for k, and this is still 0, but j becomes 2, and it runs for k, and it goes on like that. So that is a nested for loop, and you can have anything. So if you print I, this works for this loop. Print hello. This is working for this loop. It's part of this loop because you can see these two are in the same line. And this one, print by, this is part of this. So it goes into this, into this, into this, prints 3 times, prints hello, 3 times hello, 3 times hello, and then a by. So this is the order in which the loops are running. So look at closely while you run it and see. And iterating through a string. This is also there for string, list, tuple, set, dictionary, and a tuple list. So let's get started with the string. How do you do it for the string? For I in string. And before that, let's define our string as apple with print I. You get apple here. For each loop, it gets 1 character of the string. So first loop, it gets A, then P, then P, then L, then E. Also, you can just directly put apple in here and get the same result like app app. You get app here. That's how you go through a string. When it comes to a list, let's take a list for I in 6. Lists can also have different things. Okay, we didn't give anything inside. I passed it. It gives you 1, 2, 3, 6, and 8. You can also see the type. So here it's class of integer because the first loop I gets 1, so it gets integer. And at the end, it's a string. So it becomes a class of string. So that is the type function. So another thing to be noted is for everything here, if I just type I, and I can again print I here. So whatever is the last value or the last value in the for loop is what this I will be assigned to. So you can again use I after it's done. For example, if I run this loop and I print I get this P. So after the for loop is over, even then, this variable is assigned to this. So if you want to use the last thing of the for loop, instead of taking it for the last time or something like that, just take this I here. It gives you the last value. And if it's a number also, it gives a number and the type will also be the same. So for that A before or this P, it will be string. But for this one, it gets you 6, so type is integer. So that's with the list. Coming on to tuple, just give your tuple in there and you get it. And now type of I will be an integer because this last thing right here is a tuple. Another interesting case would be if I give it something like this. This is a single element tuple. Let's give 2 elements. Now this is taken as 1. So inside this will be taken as 1. It's not going to be taken as 3, 4. So even if I specify a list in here, like this, see, it's going to print you the whole list of elements. It doesn't take inside brackets. So only these 2 brackets will be considered the outer ones. So inside will be printed as this. So this at the end is a list. So it prints you a list. The same goes for even lists. So I can just have 1, 2, and even a tuple here, and it gives you a tuple. So that's how tuples can also be printed directly inside a list or nested list. And for I in this set, let's have duplicates. Yeah, forget that. Print I. As you can see, this list first it gets into the proper order. So only this much will be there. The duplicates are removed. Then the for loop starts. So this can also mean something like you can do for I in if. We'll do that later. So let's just leave it at that. And dictionary, iteration through a dictionary. So for this, let's take it separately instead of directly putting it here for understanding purposes. A dictionary is A. A has, let's give numbers. No, let's give something. Apple is green. It's a green apple. And the car is black. So that's our dictionary for I in A. Print I. And as you can see, it has printed the keys. If I give dot keys, it'll still print you the keys, but even if I name the dictionary, I'll get the keys. But I want the values, so I give dot values. I get the values. So that's how you get the values. We have also learned another one called items. This gives you a tuple type of I. That means the type of the last one here is a tuple. So a.items give you tuple. So a tuple containing the key and the value. So suppose I want them separated. We have learned something called tuple unpacking, like I comma j is equal to 1 comma 2 and I gets the value of 1, j gets the value of 2. So in the same notation, you have I comma j. So I'm just printing I, so j won't be printed. If I just want the values in j gets green and then black. We could also print both of them together. So green, which is the value of j here, green, then the value of I would be apple in the first loop. In the second loop, the value of j is black, the value of I is core, so it prints them appropriately. And as you can see, type of j is string, and now the value of j is the last one right here, which is black. So that's how we go through a dictionary. And a tuple list is similar to how we did this, the usage, of 1 comma 2. So that's a tuple list. And then here, print I. This gives you a tuple, the same case in here. So if I just give I comma j or I comma k, any name would work. And the value of I is here and this. So this is how you go through a tuple list using for loops. And since we have come till here, have we seen something like if conditions? You can even have if conditions here. So if suppose we take if k greater than 1. If k is greater than, suppose we'll take 4, equal to 4, greater than or equal to 4, then only print I. Okay, so it should be k must be greater than or equal to 4. So it starts from here. So it prints 3 and it prints 5. And you can even have your k in here. So 4 and 6. If conditions, if else, else if, elif, all can be. Else, this is interesting. I'm pretty sure. What do you think might be the answer? Have you thought about it? Maybe think it, give it a thought. And the answer is I, 4, 6. Because in the first loop, this is false because k gets 2 and this is false. So else statement is going to be executed. And in the second and the third loops, this is true. So you get 4 and 6. Same for I, because it's the same statement. Instead of k right here, you just print the I value. So that's an interesting case. So we can move on to the next one. Moving on to the last slide of control loops, control and looping statements. After this, we'll start with our functions. Great. So coming on to the while loop. So while loop is something that keeps on looping until the statement here becomes false. If I give x is 0 and then I give something like print I, and before that let's give x as 10 and print I. Okay, this just, it's all frozen, guys. This restart running fast. Will it work? Great. Look at the length. Look at the length. It just printed I for like a huge amount of time till I restarted it, until I gave the restart button. It was using all the processors and executing this I statement. This thing, the slide bar right here was so small. So almost more than 1,000, more than 10,000. Those many highs were printed, I suppose. So this statement keeps on running until x equal to, let me just do it, get it back. It keeps on running unendingly because x never changes. So always prints this. So we have learned something like x minus equal to 10, or I might have missed it. So let me just say you one thing. If I have the value of x here, okay, it's not defined. X is 10, and now I give x equal to x plus 10. What's x? 20. Instead of giving it like this, I can even give, now x is 20 right here, so x plus equal to 10 gives you x 30. If I give minus equal to 10, it gives x is equal to x minus 10. It's the same thing in a shorter form. If I give here a star, it's x star 10. The same meaning. Like I'll run this line and 200. And what about x star star? It's x to the power 10. So it's same as this line of code. In the same way, what I'll do is I'll give x minus equal to 1. Okay, and I run this. So each time it runs, it prints high, then it decrements x. So it goes until x becomes 0, and when x is 0, it stops. But if I give x minus equal to 2, each time the loop runs, it does x minus 2. X minus 2. Okay, each time it does x minus 2, and it stops when this condition becomes false. It's the same like if I give while false, it never runs once. But if I give while true, this thing right here would run infinitely because it is always true. You'll have to restart your kernel. Your computer might lag, or it might even get stuck right there because it keeps using the memory like infinitely. So that is the value. It continues executing as long as the specified condition is true. So what else could be the use of this? Let's take some interesting cases. Suppose we have something like x is 10, and while x is greater than 20, print. I know this is an easy example. Let's start with a useful case of this. So in the first one, we take the input function. So if you don't know, just start the tab and you find the input, and there's your input, and enter the secret number, and then I give a. If a is equal to SEC, let's put a secret number somewhere here. Our secret number is 10. So you can even erase it, by the way. So if I just give a is equal to h is equal to 10, ah, okay. Even if I erase it, ah will still give me 10. So just erasing a command won't take the variable out of its memory space. And then I give print that's right, else I want it to print try again. I run it and I type in 2, I get try again. But if I want to run it again, I will have to run this thing again. But as you can see, even 10 gives you an error, while what's my SEC? My secret code is 10. But why does this give me try again? Do you know the answer? You might, because A right here is a string, but SEC is an integer. So what can you do? You can do here interface, but directly writing it there like this is a bit unreadable. So you directly convert this here itself. Now, whatever value of A you type in, you get as a integer. Okay, that should be there, right? So our problem is we can only run this once. We want him to try again as long as he gets the right answer. We have seen while true. Do you think this thing runs forever? Yes, it does run forever. So we can also use this, but before using this, I'll show you another way. We can have A is 0 at the first, while A is equal to 0. This keeps on running until this is there. But when it gets the right one, A changes to 1 and the loop breaks out. So 3, it didn't work. Okay, this should not be A, my bad. Because we are assigning A to something else, the loop will break. Because we have taken A here. So if I give 4, 4, nope. But when I get the right answer, it breaks out of the loop. That's how it can be done. But what about the true? This thing, just don't run it, because this thing will run forever. So we have learned something called break in our for loops. So if he gets the right answer, it will just break out of the while loop. So 3, no, 1, no, 4, no. And I give 10. Okay, this one right here is not a number, so it gave us an error. But do you want to know what can be done if you give anything except a number? You see, you get an error and your while loop breaks. That's also one thing. How can you handle that? How can you still make it continue when you enter a no number digit? That we will learn in error handling, which will be taken later on. Later on in the sense, I'll be doing another video. Because this video might be too long for one to watch. I'll have another series, I'll have another 6-hour or 7-hour video explaining some extra topics. So I'll put that there. So I'll be, after making that video and uploading it to YouTube, I'll have its link in the description or in the comment section. So I give the proper number and it prints that's right and breaks out of the while loop. So that's while loop. Another thing is the loop with else. So we'll take the same thing, else. This else is different. This while and this else is a pair. And else print out of while loop. I print 1, you can see nothing. 2, it's still the same. But when I print 10, I get that right. But it's false. I give false, it directly goes to else part. So if the while loop doesn't run at all, it prints the else out of while loop. Like this case can be taken in the case like A is 0, but I take a equals 1, and I can give here a is 1, not, let's put this as b. So in this case, it just prints out of while loop. It's not out of while loop, it's like never came to while loop. It never came to while loop. But if this is 0, and then I guess the right number, it does this. So like if the if condition is not executed, it does the else part. In the same way, if the while loop is not executed, it does else part. But what about for num in 1, 2, 3? Print can this have an else part? Okay, let me write high. Print 1, 2, 3 high. So this one right here, it doesn't matter whether it went to the while loop, it went to the for loop or not, it prints high at the end. See this? That's one difference to be noted. While the while loop just doesn't put it if you go inside it. But if this doesn't happen, it puts in the else. But for this, it anyways puts whatever is written in the else after it's out of this for loop. So that's what is this thing. So nested loops are already done for the for loops, and this is just a loop inside a loop. So even for the while loop, similar to for loop, you just have to put the while loop under a while loop. So it might not have much or any big use cases. So it's mostly used for the for loops. So if you would like to know how it's done for the while loop, let's just take an example. We have while true, while true, if 1 greater than 2, break. If 1 greater than 2, this is false. No. Let's give this one. It breaks instantly, but we need something useful here. Print I have a is equal to 10, 10, and here we'll give a less than a greater than 0. Here b greater than 0. So it prints not I, a comma base b, a and b. And if b, let's have that before printing. If b is less than 5, we break it. Now also we'll have b minus equal to 2, while a is minus equal to 1. So I'm pretty sure you know what minus equals to means. So if you don't know, when you write a is a plus 1, we will take another letter. G is g plus 1. We'll have g as 0. The value of g now is, oh, okay. I guess running 2 while loops together is not good. So let me just, let me take this. And g is 1. So if you want to run this while loop right here, it is going to break your thing. It's going to get a lag somewhere. So what this does is, yeah, let me explain this one. Yeah. So this right here, g is equal to g plus 1 can be written as g plus equal to 1. So if I write this and I type g, I get 2. If I want g minus, if I want star, all those symbols can be changed here. This is g is equal to g minus 1. G is g star 1. Can give g divided by 1. See, divided by, even g percentage is, it's going to be g percentage 1. And also I can give star star, which means exponents. So it's like g to the power 1. So g 0 to the power 1 is just 0. So you get 0. And coming on to this, say if I don't have this break statement, you'll get a star here and it wouldn't stop soon. So what it does is it goes into this loop. After that, it directly jumps to this loop. So B will be 10. So it prints 10, 10, and then it goes to this one right here. B minus equal to 2. This thing, this loop alone will be running. So this loop will be running until this thing right here breaks. So if I don't have this break statement, I put one high here. What happens is this loop will run continuously. See the high. Stop. Wait. It's converted to break. Okay, so this break is really important. Nested while loops are not typically used. They are used in some cases, but for this thing, why it doesn't work is, let me take you an example. So right here we have B is 10, A is also 10. I mean, I'm telling you why it goes endlessly, even though we are decrementing it by -1 here. So A is 10, B is 10. In the first while loop, we need A greater than 2. On the second while loop, we need B greater than 10. So we have seen in the for loops, if you have two for loops, after this loop is completed, then it goes to the next iteration of this loop, right? So if I had for A in range 3, B in range 3. So after, if you are printing B, print B, let's say A comma this right here, it will give you 0, 0, 0, 1, 0, 2, then it goes to 1, 0, like this. So after this loop right here, this one runs completely, then only this one gets, because after running around for 3 times, it comes here. So there is no more line of code. It goes back to this one. In the same way, when we are running this right here, we have if condition b less than 5, then break. And we also have something called printing the print. This is the print statement. And this is b equals -2, a equals -1. So when b is less than 5, that means what's the value of a? So at the first, b is 10, A is 10. So it runs through this and you get 10, 10. So this is A. Then it becomes 9, 8. Then 8, 6, right? 8, 6. But now in the next loop, we get this right here, this thing as 6, and this one would be 7, 7 with 4. So 7, 4. So B is 4. So always this one break statement right here can't break this loop here. It breaks out of this loop. So when it directly goes and breaks this thing, these statements won't be happening. So always, now onwards, after B becomes 4, always the value of A will be 7. Because as it enters this loop right here, this statement becomes true because B is always 4 now, and it breaks out. So it then goes to this while loop, and since A is always 7, it will run infinitely. So what could be done is you could either have something like, let's take, what if you put this here? If you put this here and run it, it works fine. So this break statement, let's remove the break statement here also then. And this works fine. So while using two while loops, what I'm saying is make sure you don't get the infinitely running loop, because when you're breaking out with just a single break statement, it only breaks from one loop. It doesn't break from the second one. So if you want to break from the second one, you need one in the same line as this while loop. This while loop is one indentation. So everything written starting from this line belongs to this while loop. And everything written from here belongs to this while loop. So that's a point to be noted in nested loops. And now we are done with looping and control statements. We can go on to the next.